In the present video, we'll be discussing the solutions to question number 11 and 12 in NCERT Physics Chapter 3 for class 12, that is current electricity unit. Question number 11 is a storage battery of EMF 8 volt and internal resistance 0.5 ohm is being charged by a 120 volt DC supply using a series resistor of 15.5 ohms. What is the terminal voltage of the battery during charging process? What is the purpose of having a series resistor in the charging circuit? So you are given the EMF of the battery as 8 volt, the internal resistance denoted by small r as 0.5 ohm, the voltage of the source, charging source is 120 volts. The series resistor used is 15.5 ohms. You have to find the terminal voltage. You have to state the purpose of the series resistor in the charging circuit. The question for our reference, the diagram shows the battery with EMF E, the external source, and we have a resistance 15.5 ohm in the charging circuit. We know that in during charging process, the current has to be forced through the battery. So positive of the external source is connected to positive of the battery. So normally when we draw the current, it flows from positive to negative, but here we are forcing it into the battery from in this direction. That is, we are opposing the battery with the help of this external source. We are given EMF as 8 volts, external resistance 15.5 ohms, internal resistance 0.5 ohms. External voltage is 120 volts. So the external voltage minus the battery EMF is I into R plus R, because the net voltage available will be external minus the battery voltage, and it will drive current through external resistance as well as the internal resistance. So we have the total potential drop as I into the total resistance, and what is available is E external minus the battery EMF. Substituting the values, we get 120 minus 8 means 112 equal to 16I, because total resistance is 16, which gives us current I as 7 amperes. The terminal voltage while charging is always greater than the EMF of the battery. So it is capital E plus IR. Substituting values, you get the potential drop or terminal voltage as 11.5 volts. This resistance, external resistance, basically restricts the current flowing through the circuit, because in absence of this, the EMF available, the voltage available will be 112, and the resistance will be only 0.5. That is, the current will be more than 200 amperes, which is very large current. So in order to restrict the charging current, we make use of the external resistance in this circuit. Question number 12. In a potentiometer arrangement, a cell of EMF 1.25 volts gives balance point at 35 centimeter length of the wire. If the cell is replaced by another cell and the balance point is obtained or shifts to 63 centimeter, what is the EMF of the second cell? Question for your reference. For solution, we have to first record the data. We are given EMF of the cell as 1.25 volts and the balancing length L1 equal to 35 centimeter. The balancing length for second cell of unknown EMF E2 is given to be 63 centimeter. We know that the potentiometer works on the principle that the EMF is proportional to the balancing length. So we get E1 by E2 equal to L1 by L2, which implies E2 is equal to E1 into L2 by L1. Substituting the values which are given to you, you get the EMF of second cell as 2.25 volts. You may like the video and subscribe to our channel CBSE 042 for future notifications. Should you have any feedback, please write to ikg54@yahoo.co.in. Visit our blog www.physicsbeckons.wordpress.com for more topics. Happy learning and thanks for watching. Thank you.